Hello everyone, myself Heyman. Welcome to you ELectro-AI. So let's deep dive into the coded part, or the coding part of the ELectro-AI, how we have coded and how the training of the model has been done. So before that, let's talk about the dataset we have taken elect to train the LSTM and RNN model of the ELectro-AI. So let's start. So we have two types of model, LSTM and RNN, and both are trained on two types of dataset. First is DOM hourly dataset and second one is PGMI hourly dataset. Both datasets are based on energy consumption datasets. So you can see this dataset is about DOM dataset, date time, where we have dates and time and the energy consumption of that time. Now, so we have seen DOM dataset. Now let's talk about PGMI. So here the PGMI dataset. As you can see, same as DOM dataset, it also have date and time and energy consumption on that date and a particular time. And we have another dataset that we have created, which is will be used for the next model of the ELectro-AI series, so that we can predict accurately based on multiple factors. As you can see, this dataset contains date, year, month, day of week, season, temperature, climate type, humidity, wind speed, rainfall, holiday, population, density, industrial activity, residential commercial power ratio, air quality, solar radiation, power consumption. Now, as you have seen the data set, now let's deep dive into the code part. So, so you have I am hoping that you have checked out the model, the streamlit version of the model. So here, when you open the repository, as you can see the datasets, and we have also a AAP our dataset. You can see it is the same as the DOM dataset and PGM dataset. You can check now. So we have two types of model, LSTM1 and RNN1. So this file model.ip1 here in this LSTM model we have taken the data, or the dataset is DOM, and for the model 2 part we have taken PGMI dataset, as you can see now. So this in this part we have importing the libraries, so to run our code, as you can numpy, pandas, pickle, and matplot to plot the graph, sklearn, tensorflow, keras, and keras, like we have imported dense, dropout, simple, and LSTM. And from keras.model we are importing sequential models so that we can stack multiple layers of the model. Now in this part, we have imported the dataset, and here we have printed the first 5 rows of the dataset, and then we have taken the info of the dataset. Now we have converting it into date time data frame. Here we are indexing the date time, and here we are in this part we are checking the missing data. Now in this part we are checking year, like to the unique year, like as you know, we have indexed the date time, so from that index we have taken year, and every year unique part, so you can see. And this is average of yearly, consumption. Now, in this graph, we have seen the energy consumption from 2006 to 2018. As we know, the DOME dataset contain energy consumption data from 2006 to 2018, as you can see. Now, in this version, we are normalizing the energy consumption in the dataset. Why we are normalizing? Because it helps to train the model efficiently. As you know, the dataset contain multiple, or you can say some values are more higher and some are both lower, to which you can say restrict or increase the time of the training, and also it affects the efficiency of the model. So we are normalizing it into between 0 to 1 so that we can train the model efficiently. So this, as you can see, now the consumption is in the consumption column is in between point 2 3, or you can say between 0 to 1. Now we are plotting the graph from 0. You can see this is you can see the year, and the left hand side we have the in the energy consumption column we have the values from 0 to 1. Now now we are splitting the date so that we have training data and the testing data. As you can see, the line on the graph is indicating 13 February 2017, and the training for the training part on the graph you can see the blue region on from the left hand side of the line. It is the training data, or you can say before 13 Feb 2017 we have the training data, and after the 13 Feb 2017 we have the testing data. Now in this function we are just loading the data, or you can say we are preparing the data for testing and training part. And this is now important part. In this part we have imported sequential layer so that we can stick multiple layers of the LSTM model. As you can see, I have taken 7, as we have tested many combinations, that around 10 14 15, to test the efficiency, or you can do the accuracy, and how close the model will reach to the testing data. And the ideal number we have reached is 7. And here we are just compiling the model and start training of the model. And I have taken training time of which is 32, because based on the testing I have reached the number, the number it should be more closer to 30 or 32. And here you can see the R2 score. R2 score for the DOME dataset, and the model we have trained it is on LSTM1 is 95%. Now, as you know, we have normalized the score earlier, so now we are converting the normalized score to the actual values. So here is the one. Actual value was 11 for the time. So the A, as you can see, this is the tested data we have taken, and that on the basis of prediction we can see the actual data was 11,494 megawatt, and the prediction it made is 10,893 point something. And you can read all things. Now let's plot it in the graph. As you can see, this is the graph. The more it reaches to the blue part, the yellow region one, the more closer or the more efficient the model is. And what is the blue part? Blue part is actual power consumption, or you can get tested data, we have taken, and the yellow part is the predicted, the model has predicted. Blue part is the actual one, and the yellow part is the predict. Based on it, we have predicted, and the last part we are just compiling them, or you can say I am making model into pickle so that we can use it in our application. This is the LSTM one, and the same goes for RNN also. So as you can see, I've so here is a DOM dataset we have imported. Now all the things are same here and here. Now the model we have taken is RNN, imported the sequential layer, so sequential model, so that we can stack multiple layers of RNN, or a same say, thing as LSTM1. Here also the the number of layer we have taken is 7 based on testing, and the training time, or you can say, which is 32. Efficiency is 91, and it is actual data, and it is the predicted one. And here you can see the graph. So this is for the DOM one. Now let's talk about the PGMI one. And same, before going to PGMI one, let's talk about also. Here also we are compiling the model so that we can use it. You can see here. Now let's go for PGMI one. Now we have imported PGMI dataset. Here is the megawatt power consumption, and here the date and time. Same, all the things are same here. Same. You can see we're loading the data, and for the training we're dividing dataset. Same layer, 7. Now what's different, right? The different part is here. Now the efficiency is 97%, 97.9 something, or you can say 98. Before it was around like 95, I guess. Yeah. Hmm. Before it was 95, and now it is 97, which is a huge success. Or you can say. Now this is also same, just we are reversing the values. As you can say, we have normalized the data, now we are reversing it. And here the prediction graph, same concept. The more closer to the blue one, the more it reaches the actual value. As I've told you earlier, the blue one is the tested data we have taken, and the yellow part is the how far, or the how close the prediction is made. And this is for the this is LSTM model for the PGMI one, and next RNN model for the PGMI dataset, right? All the things are same as I've told you. Now I have told you earlier. PGMI dataset contain data from 2002 and from 2018. So the training data will increase, right? So as you say, we have taken this line is telling us is that the blue region, or you can say the data before 13 Feb 2017, the training dataset, and after that is the testing dataset. And here is the RNN model. We have imported sequential model so that we can stack multiple layers. Now is the training part, and the efficiency here is 96%. Earlier in DOM dataset it was 91 around. Now it is 96. All the things are already the same here. Now we are just the as you know, we have normalized the data so that we can make our training time, or you can say the efficiency of model easier, and now we are converting it to normal values. And here the prediction graph of the values. You can see many regions with yellow where it's coinciding with blue part, or you can say actual testing data and the prediction. Actual testing data and prediction are coinciding on the same line. Thank you for my